Rahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Kenneth S. Crane. As usual, we first come to its statement. Calculate the binding energy per atom for metallic Na, sodium, and Cu, copper. Dear students, Na actually comes from Latin word natrium, which denotes sodium. Okay, sodium and copper Cu. Cu coming from Latin cuprum. Okay, copper in Latin cuprum. Calculate the binding energy per atom for metallic sodium and copper. Calculate the binding energy per atom for metallic sodium and copper. As usual, we first come to helping tools. Okay, after statement we come towards helping tools. Helping tool number 1. In helping tool number 1, a table has been shown. We see what is the speciality in this table. Okay, we are concerned with the sodium and copper. Okay, so in this table we see whether sodium and copper exist. Yes, this is sodium and this is copper. Okay, natrium and cuprum. Natrium, sodium, nearest neighbor distance in nanometer 0.372, while for copper, nearest neighbor distance in nanometer is 0.256. Moreover, cohesive energy in kilojoule per mole for sodium is 107 kilojoule per mole, and for copper it is 337 kilojoule per mole. Okay, so remaining part of this table is of no use for us. Okay, so we have gone through the abstract of table, first table. Okay, first table, in third and fourth row, sodium and copper are included, and to the extent of this problem we are concerned with cohesive energy in kilojoule per mole, which is in case of sodium 107 kilojoule per mole, and in case of copper it is 337 kilojoule per mole. Now we come to helping tool number 2. In helping tool number 2, mole or Avogadro number has been defined. Okay, 1 mole of a substance contains Na, capital N, capital N, capital A, where capital A is written as a subscript of capital N, Avogadro's number. Elementary units, usually atoms or molecules, where capital N, capital A, where capital A is written as a subscript of capital N, is found experimentally to be capital N, capital A having been written as a subscript of capital N equal to 6.02 into 10 raised to the power 23 per mole. Mole inverse means per mole, within bracket Avogadro's number. Okay, 1 molar mass capital M of any substance is the mass of 1 mole of the substance. Or now alternate version of this helping tool has also been given. Okay, the number of molecules in a mole is called Avogadro's number, denoted by Na. The current best numerical value of Na is Na equal to 6.022141229 up to 27 decimal places into 10 to power 23 molecules per mole, Avogadro's number. Okay, we have many times gone through this definition and concept. However, it is because it is very relevant in this problem, so here once again it has been gone through or taken into consideration. Okay, next in helping tool number 3, a table has been included. This table has been included so many times in our previous problems, previous videos. So due to this reason, we for the time being we skip details of this table. Okay, now we come to solution. Okay, we know that the relationship between the molar cohesive energy E co, where co or cohesive has been written as a subscript of capital E, and the ionic binding energy capital B is given by E cohesive E co, where co is written as a subscript of capital E, is equal to half capital B into 2 Avogadro's number. Dear students, 2 cancels with 2 and hence E cohesive energy becomes equal to binding energy into Avogadro's number. Okay, quite simple. Cohesive energy has become equal to binding energy into Avogadro's number. Now we come towards sodium, Na, sodium, natrium. Okay, first we discuss sodium. Now we know that cohesive energy E co is equal to binding energy into Avogadro's number. Then this implies that binding energy is equal to cohesive energy divided by Avogadro's number. So this becomes equal to 107 kilojoule per mole over 6.02 into 10 raised to the power 23 per mole. Okay, dear students, this is actually just a number, 6.02 into 10 raised to the power 23. So while expressing Avogadro's number, it is not appropriate to write atoms per mole or molecules per mole or other entities per mole. Okay, it is just a number. So dear students, binding energy has become equal to cohesive energy divided by Avogadro's number, and we have put the value of cohesive energy from table, and we have also put the value of Avogadro's number from helping tool. Okay, so both helping tools have been properly utilized here, and binding energy has become equal to this over this. Now here, dear students, mole will be cancelled with mole. Okay, because in the numerator mole is in the lower part, and in the denominator mole is once again in the lower part, so it will be reverted. Okay, lower part of the denominator will be shifted to a numerator, and hence mole will be cancelled with mole, and our expression will be reduced to binding energy becoming equal to 107,000 joule over 6.02 into 10 to power 23. What we have done, in place of kilo we have used 3 zeros. Okay, we have eliminated or we have substituted K by 1000, its value. Okay, now dear students, we are going to make a substitution, a conversion factor. What conversion factor? We have in place of joule, we have expressed joule in terms of electron volt. How we have taken this step? For this, we will have to go a step, two steps behind. Okay, yes, this is. Dear students, in the last row, it is written that 1 electron volt is equal to 1.602 into 10 raised to the power minus 19 joule. Okay, so it means 1 joule will be equal to this 10 raised to the power minus 19 will be, when shifted on other side of equality, it will become plus. Okay, then 1 joule will be equal to 10 raised to the power plus 19 into 1 divided by 1.602. okay, electron volt. Okay, the last conversion factor has been used in our solution in the sense that it is actually 1 electron volt is equal to 1.602 into 10 to power minus 19 joule. From here, we have made a substitution that 1 joule will be equal to 1 divided by 1.602 into 10 raised to the power plus 19 electron volt. Okay, 1 electron volt is equal to this, then 1 joule will be equal to this over this into this. Okay, so quite simple. Now we come back to this. Okay, here what we have done, we have just made use of a conversion factor in which joule has been replaced by electron volt. Okay, next only simplification. Except simplification, there is no other thing. Okay, so after simplification, binding energy B becomes equal to 1.109493 electron volt. This is our solution of the problem. Because our problem consists of two parts, this is the solution of a first part. Okay, dear students, here value of binding energy B can be taken as rounded, as in place of 1 2 3 4 5 6, in place of 6 decimal places, we can write it as 1.11 electron volt. Okay, because after 0 digit is greater than 5, so we can increase this by 1, and hence 1.11 we may write. But even if we write it in this form without any change, it will be acceptable. Okay, now we come towards copper, Cu. Okay, dear students, for copper we have not used the symbol capital C small o, rather we have used capital C small u, because it is cuprum in Latin. It comes from Latin cuprum, so that is why in place of CO it is Cu. Okay, now we use the same arrangement in our previous calculation of sodium. Okay, the only difference is that here we are dealing with the copper in place of sodium, natrium. Okay, so E cohesive energy is equal to binding energy into Avogadro's number. This implies that binding energy is equal to cohesive energy divided by Avogadro number. This implies that this becomes equal to 337 kilojoule per mole divided by 6.02 into 10 raised to the power 23 per mole. Here mole will be cancelled with mole, and hence we will be left with this. What we have done here, we have just replaced kilo K by 3 zeros, that is 1000. Okay, next again same procedure, here in place of joule we have used its conversion factor in terms of electron volt. Okay, so we have adopted the same procedure as we adopted in case of sodium natrium. Okay, so after simplification it will become, binding energy will become 3.49436 electron volt, and we can reduce it up to only one decimal place as 3.5 electron volt. Okay, because digit after 5 is greater than, digit after 4 is greater than half, that is 5. So, so it can be increased by 1. So even this expression is acceptable. Okay, that is binding energy equal to 3.494386 electron volt, or we can also write it as 3.5 electron volt. And this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.